Good morning, statistics students. Today we're going to do standard deviation. Since the recording didn't work in class today, I'm recording this in the office and everybody's looking at me funny. So standard deviation is a measure of spread. Yesterday we did a measure of spread called IQR. If you think your center is the median as opposed to the mean, you would use the IQR as a measure of spread. If you are talking about the mean as your center, you use standard deviation as spread. When would you choose to use the median as your measure of center? When your distribution is skewed to the right or to the left. When do you choose the mean? When your distribution is symmetric, short on the ends, the tails, high in the middle. Uniform, all the bars are essentially the same height. And when we have some other different ways that distributions look, we might have something that is two lumps, two sets of high bars. I would call this bimodal. And I would not use the mean or the median to describe the center of this data. I would reconstruct my data. I think we have a lurking variable going on here somewhere. We'll talk about that later. And so I might want to divide my data up into two parts, since I have two distinct peaks here. All right, so standard deviation as a measure of spread. When we think of standard deviation, now here's the concept for standard deviation. Standard deviation is the, quote, kind of a average distance each value in my data set is away from the mean. So that's my concept, and we'll work with this concept, and you'll ask me, about 5 more times during the year. Now, wait a minute, what's standard deviation? Well, it's the average distance the values are from the mean. It's a strangely calculated average. Standard deviation, the one that is called the sample standard deviation, is abbreviated with an S, and the formula for it is I take each one of my values in my set, I subtract off the mean, I square that difference, then I add all of those for each value up together, divide by the number of values I have in my set minus 1, and take the square root of that whole thing. So let's try to calculate standard deviation. I'm going to give you a small data set. 1, 2, 7, 10, 15. And first we'll calculate the mean. Oh, well, that should be pretty easy. 1 plus 2 plus 7 plus 10 plus 15. And I divide it by 5. Oh, that's 35 divided by 5. I have a mean of 7. Okay. That's an interim calculation. My next interim calculation is going to be my variance. And the variance is the standard deviation calculation without the square root. So the variance, I'll call it f squared in this case, is going to be the sum of the square of the difference of every value and the mean, 7. So I have 1 minus 7 squared plus 2 minus 7 squared plus 7 minus 7 squared. Oh, 0, that's easy. Plus 10 minus 7 squared plus 15 minus 7 squared. Sum all that up and divide it by n minus 1. The number of values I have, 1, 2, 3, 4, 5. So divide that by 5 minus 1. And I get 134 divided by 4 gives me what we call the variance of 33.5. Now the standard deviation, and I'm going to start abbreviating because that's a long word to write. The standard deviation that we call S is the square root of the variance. So that's the square root of 33.5, which is approximately 5.79. So that tells me that each one of these values, 1, 2, 7, 10, 15, on average is 5.79 away from 7. Okay? This is a measure of how spread out my data is. If that number is really large, then my numbers are kind of all over the place. If that number is really small, that means my values there are packed very tightly around the center, around the mean. That's all.